Hey, what's up? What's up? How are you guys doing? It is Tuesday, October 31st. Yeah, let's move it along. Oh, so I'll move out the way. Bam. You know what to do. We're moving along. Okay, so hopefully everyone got all of this done. Let's just go through these. So for number one, acceleration, right? Which one of these ones could be acceleration? Remember, acceleration is two things. It is a change in direction. It is also a change in speed. So because of that, that means the change in object speed is A, and a change in object's direction is C. So that would make it D, which is both A and C. Okay, moving on down to here. So a trash, and what of these three situations is the object accelerating? So they're just talking about acceleration, which is what we just talked about. So it's a change in speed or a change in direction. So if they talk about a trash truck takes off from the curb, that's like a change in speed because it's taking off. It's going, starting to accelerate, right? And then a book on the shelf, that would definitely not be that answer. And then an airplane that is banking around an airport. And just so you know, when an airplane is banking, it's like this, right? So here's my airplane. When it's banking, right, it's tilted, just like the banks of a river. So like a river bank is tilted that way. That's what it means, that angle. And then so it's going around. And since it's going around, it is constantly changing what? Hopefully you got it, changing direction. So that also would be acceleration, okay? So then that means the answer to that one would be 1 and 3. So both 1 and 3 is C. Okay, when a police officer is trying to decide if a driver is speeding, what is his point of reference? And that is going to be his car. Just a couple things. When you think about the speed limit itself, the idea of the speed limit is just an idea, right? That we wrote down and we said, okay, the speed limit is 25 mph. That's just what we said. So unless we have a physical sign out there, we can't use that as a point of reference to say how fast an object is going. If we just know that the speed limit is 25 miles per hour in front of the school, that knowledge will not allow me to know how fast the car is actually going, right? I may be able to stand out there and say, like, it seems like that car is going, but I won't be able to, it's hard. So, and how I know that it's going faster is because of my point of reference. So the physical thing. So again, if I had a 25 mile per hour sign out there, that would be a physical thing that I could use as a point of reference. But the speed, knowing the speed limit itself is not, because the speed limit is actually an idea that we agreed upon to say this is how fast someone can drive. Okay, so the ground, if you've been in an empty field, you know how difficult it is to see how fast something is moving. And the main reason people are like, because you have nothing to compare it to. And that's what it means by reference. It means there's nothing to compare it to. So again, the point of reference that is the best one, right, would be the police officer's car, and they can do this in several ways. They could be going a certain speed, and then be seeing how fast your vehicle is going into reference to their vehicle. They could also use it by their vehicle is steel, and then they can see how fast you move past their vehicle. So there's different ways for them to use their car as what I would say a frame or a point of reference. It probably is not the only point of reference that they're also going to use. Okay. Number 4, which help you to determine the meaning of the word decelerate in paragraph 1 and 3, or is that in paragraph 3? In paragraph 3. So most people went with causing the car to slow down, and that's just this idea of it's just that my acceleration is decreasing. So I could be going this and then sorry. So I still have acceleration, but my acceleration just has decreased. My amount of, or my magnitude of acceleration has decreased. All right, and then down here for a bowling ball, moves at 18 meters every 2 seconds, right? And down a lane in the alley, what is the speed of the bowling ball? And so they want you to calculate speed. So hopefully you remember that speed, right here, I'll make myself bigger right here. Speed is equal to distance divided by time, which is also equal to, since the distance in this case is 18 meters and the time is 2 seconds, then we'll end up with 9, oops, don't mean to do that, meters per second. Does that make sense? I totally would write this down in your book, so you might want to pause the screen, write this down in your book right underneath the problem. Okay, cool. So we got that in. Make sure you guys actually turn this in, and if you haven't turned it in already. Also, you should check it out to be like, how did I do? This was a quiz, because technically inside the book, it's given to me to say I could use it as a quiz. If this was your quiz, how would you do? How would you have done? So just think about that. So these are some of the questions that and things we've been going over. So how well are you doing, right? Cool. Let's move it along. So what I want you to do is take time and pause the screen and answer the questions on 73, and then go ahead and answer the questions on 74, and then we will go over them together. All right. Hopefully you got that done. Now, here we go. So if mass increases, what must happen to the force in order to achieve the same change in motion, right? So it is this idea, right? This idea here that, okay, cool. So let's just say I got this, right? I got this little cough drop, okay? And I'm just gonna throw it. I'm gonna put it on the desk, okay? So you can be able to see that. Okay, cool. So you saw that kind of change of motion, right? You saw that change of motion, right? Now, if I up the mass, right? So if I get something more massive, right? So I get something more massive, right? If I throw it with the same amount of force, will I get the same change of motion? So look, I'm gonna try and use the same force. Okay, so you saw the change of motion was different. In order for me to get the same change of motion, what do I gotta do? Apply more force in order to get it to travel the same distance or to get the same change in motion, okay? So just realize that. It's just like this. I could use the same object, right? I could say like this. I could say, okay, cool. I'm going to use this force. I'm going to go boom, right? So I just whoop, whoop. But if I increase the force, right? I increase the mass, right? So I increase the mass. I put some things in. Can I get this? Oh, I can. No, I can't. I can't get that in there. So I'll just increase the mass. I'll put some things in here. So I'll just increase the mass. Now that I've increased the mass, I'm going to try and use the same amount of force. Bruh. And again, when the mass goes up, right? Again, mass goes up, more force is needed in order to get the same change in motion. This is why a diesel has a much larger engine that can produce much more force than a regular car, because it has so much more mass that it has to get in order to achieve that same change in motion. Okay, cool. So that's that. So here's my mountain, flat out. So a boulder sits at rest on top of a mountain. This is the cotton candy mountain, okay? And then here's my boulder right here. Boop. Okay, that's my boulder right there. That's my boulder, right? So what conclusions can be made about the forces acting on the boulder? So a lot of people came up with the net force is 0, which is true. Some people also came up with the idea that that the forces are equal, because the force of gravity going down, right? So the force of gravity going down and then the force of the mountain pushing back up on the boulder are equal, and that's why the boulder does not move. And that is correct. And just remember, when it says at rest, it means the object is not in motion, has 0 motion, 0 velocity, 0 acceleration, 0 speed. It's just the object is at rest, okay? All right. Now, let's go here. Let's talk about this. A diagram of forces being applied to a box by 4 people is illustrated. Hold on, let me see if I can. Yep, okay, is illustrated below. If the net force acting on the box is 10 newtons to the right, what is the magnitude of the force being applied? Now this one, okay, is a little bit complicated. So we're gonna work this whole thing out. So it says the net force, right, of the box is 10 newtons, right? So 10 newtons to the right, okay? So that should be what everything is equal to at the very end, okay? So now I need to look at, what do I have to the right? That's what I'm going to look at first, because I have this one to the right. I mean, that one's to the left, this one's to the left, and that's the one I'm trying to find, this one right here. So I have this one to the right, and I have this one also to the right. So that's 11, and I also have 21. So I'm going to say 11 newtons to the right plus 21 newtons to the right is equal to what? And that is 32 newtons, okay, to the right. Are we good with that? 32 newtons to the right. So we're good with that, okay? So I'm gonna just put this down here. 10 newtons to the right. That is what we got to end up with. Okay, now the one other known thing that we know is down here where it says 8 newtons to the left, right? 8 newtons to the left is going in the opposite. So they're not pulling together. So I know that that should be subtraction. So 8 newtons to the left. And what I get out of there is 24. So 32 minus 8 is 24 newtons to the right. Okay, you see that? So 8 minus the 24. 32 minus 8. Right there. 32 minus 8 is the 24 newtons to the right. Now, right here, this is where we got to start using some logic. We could also like make a variable and solve for x, but I don't want to make it too complicated. This is the problem we're left with. 24 newtons, right? 24 newtons to the right minus what? How do we get it to be 10 newtons? And most people said, oh, that must be 14 newtons to the left. If it's subtraction, it has to be to the left. And that is the one that we're trying to find. This one right here, the 14. So that is what that gentleman is pulling right there. Hopefully that made good sense for you. We kind of walked through that a little bit different in each class to make it make sense for the people. All right, that is it for today. Tomorrow we're going to go over best practices for the CER and then get started on the CER. Definitely what I would do, because in some classes I got a little bit further than other ones, is I definitely would, let me just go ahead, is look in your rough draft and be like, hey, do you have all these pieces? We'll look at these in detail in the next lesson for tomorrow. But do you have all these things? Does your claim answer your question, right? That's very important. Does your claim answer your question? Do you have 3 pieces of evidence, right? And then for your reasoning paragraph, is there an intro with the question and claim? Are there the 3 pieces of evidence inside of your reasoning paragraph? And then is there a conclusion? So we'll look at these in detail tomorrow. All right, y'all. Peace.